Today we're going to be doing stuff with the distributive property, which you should have learned last year, so hopefully it doesn't take too long to remember it. You might remember it now. Um, but there is kind of a way that I do it where we do like, the number on the outside of the parentheses times the number on the inside. But whenever I do it, just make it more fun, I go shoo, shoo. So if you want to make the shoo sound, you can. It's completely up to you. If you remember how to do distributive property without making the shh sound, then by all means don't make it. This first blank is going to be like terms, which hopefully you have heard of before. Like terms are terms that have the same variables with corresponding variables having the same power or exponent. Um, so we could say that 3x and x are like terms because they both have an x. We could say 3 and -7 are like terms because they both don't have a variable. We cannot say 3x and 4y are like terms because they have different variables. And you can't say 3x squared and x are like terms. They both have an x, but this one has two x's, this one only has one, so not like terms. So it needs to be either no variable at all or the exact same variable with the exact same exponent. Now we're going to combine like terms when we add and subtract. When multiplying and dividing, it doesn't matter if they're like terms. You can multiply and divide whatever you like, but adding and subtracting, they must be like terms in order for them to get added together. So on the next page, we're going to look at some examples where we are simplifying an expression. So these are going to start off pretty basic, and then I'm going to write an additional one off to the side. So for number one, we're going to go shoo, shoo. So the distributive property is helpful anytime you have a number directly on the outside of parentheses and a variable on the inside. If there's no variable on the inside of the parentheses, then you don't really need to do it. You can just simplify it on your own. But anytime a variable is involved, you will want to do this. So when we do this, we are multiplying all the terms on the inside of parentheses times whatever's on the outside, which means we're doing 7 times 3w. Oops. Minus 7 times 5. So 7 times 3w is 21w, and 7 times 5 is 35. So this is your final answer. Do not put 21w minus 35 together. Don't actually subtract those because they're not like terms. So we're just going to leave them apart. Since they're not like terms, they don't like each other, they like to be apart. And you don't really have to write this step. I just wrote it so you can see exactly what I'm doing. Number two, go shoo, shoo, shoo. So 4 times 6v squared is going to give me 24v squared. Make sure that v looks like a v. 4 times v is 4v. And 4 times -3 is -12. Notice I said -3, so even though it looks like subtraction, it's also a negative. So whenever I'm doing this, I like to think of addition problems as being positives and subtraction being negatives. It helps me figure out my signs when I go to write it out. So this is your final answer because we can't combine anything else because those aren't like terms. Number 3, shoo, shoo, shoo. So -6 times r is -6r. -6 times 3g is -18g. -6 times -f is a positive 6f because a negative times a negative is a positive. I don't have any like terms, so I'm done. I will show you an example here in a little bit where we do have like terms, so we're going to have to do a little bit more simplifying. Number 4, -4 times -8 is a positive 32. -4 times -3m is a positive 12m. So you can leave it like this, or if you prefer, you can switch the 10m and the 32, just because in algebra, typically the variable will come first. Now I'm going to write an additional problem right here, number 5. I want you to solve -2 times 3x minus 4x plus 7. Now, two ways to think about this. You could go ahead and simplify what was on the inside and then do what we've been doing, or you can go ahead and start the distributive property. So I'm going to start the distributive property. So negative 2 times 3x is negative 6x. Negative 2 times negative 4x is a positive 8x. And negative 2 times 7 is negative 14. Now, I want to look to see if I have any like terms, which I do. I can do negative 6x plus 8x, which would give me 2x. So 2x minus 14 will be my final answer. Please do not leave it like the second step, because that's not completely simplified. Okay, the next four problems, they do not involve the distributive property. They just involve simplifying by combining like terms. Sometimes you'll have a problem that you can't combine anything, in which case you'll just write already simplified. That's why it says if possible. So for number 1, we have 6n minus 4n. Those are like terms, so I can put them together to get 2n. And notice there is no work to be shown. b squared plus 13b plus 13. There are no like terms because this b has a square, this one doesn't, so they're not the same. So I'm going to write already simplified. Number 3, looking for like terms, I see 2 right here. So I'm going to bring down my 4y cubed. 2y minus 8y is negative 6y, and then plus 5. And just double check, no other like terms, so I'm done. Number 4, we have two terms that have AB, so these are like terms. It's okay that you have two variables in it. They're both the same, they both have AB. So 7AB minus 2AB, that says minus, is 5AB. Bring down your plus 4, bring down your minus 6A. Looking for any more like terms. This one has an A just like this one, but it also has a B. Since this has a B and the last term doesn't, we can say that they are not like terms, so we are done. Okay, so that's all the notes for today. If you have any questions, feel free to email me.